Hi everyone, welcome back to ChemHelp ASAP. In this video, we are working on the periodic trends of ionic radii. Now this is how we're going to predict if ions are bigger or smaller based on their position on the periodic table. Let's get started. Let's take a look at the periodic trends in ionic radii. So remember, an ion is a species with a different number of electrons than whatever the parent or the neutral atom was. So we have two different kinds of ions. We have a cation. This is a species with fewer electrons than the parent atom. Cations are generally smaller than their parent atom. They also have a positive charge. We also have anions. These are species with more electrons than their parent atom. Anions in general are larger than their parent atom, and they will have a negative charge. So let's take a look at lithium. So lithium as a neutral atom has a radius of 152 picometers. However, when lithium becomes a cation, its radius changes to 76 picometers. So you can see it becomes smaller. Now let's take a look at chlorine. Chlorine as a neutral atom has a size of 99 picometers. But when chlorine becomes an anion, you can see it becomes much larger. It has a size of 181 picometers. So chlorine becoming an anion means its radius increases. Now let's take a look at our trends. So this is clearly not the entire periodic table, but when we talk about ionic trends, we tend to only talk about the main group elements. So you can see here are the group 1 elements, here are the group 2 elements, and then we switch over. Here is group 16 and group 17. Obviously, your noble gases are not going to form ions, and there isn't as much consistency in the middle of the periodic table, the D group elements. So again, we just talk about main group elements. So let's see the trend. What I am showing here is I'm showing the neutral atom size and the ion size. So you can see as we move from right to left, our size of our atom is increasing, but also the size of our ion is increasing. So the lithium ion is larger than the beryllium ion, but you can see the same thing if we go over to oxygen and fluorine. Again, oxygen is a little bit bigger than fluorine, but also in the ions, the oxygen anion is bigger than the fluorine anion. So our ionic size is going to increase as we move from right to left. Now let's look down a group. If I compare the lithium ion to the sodium ion, you can see the sodium ion is bigger than the lithium ion. The same is true about potassium. Between sodium and potassium, you can see my potassium ion is bigger. And on the anion side as well, if I look at my fluoride ion, it's 103 picometers. My chloride ion is bigger at 181 picometers. And my bromide ion is even larger at 195. So as we move down a group, we are going to be increasing in ionic size. So to summarize, our trend is right to left, we're going to increase in ionic size, and top to bottom, we're going to increase in ionic size. Keep in mind that an ionic radius is not the same thing as an atomic radius. However, putting those together, like we saw in our table, can help inform you in terms of why things are bigger or smaller. I hope you found this video helpful, and thanks so much for watching.